All right, number 24, we have a graph. We want to determine what this is. Now, it's an absolute value, so its parent graph is simply that. But we took it and we made it move over 2 units to the right and down 1 unit, didn't we? So how do we slide it 2 units to the right? Well, what we do is within that x, to move it to the right 2, you have to subtract 2, the opposite of what you would think. And then to slide it down 1 on the outside part, you just put -1. There we have it. There was an absolute value. We have to know that it's an absolute value, though. Just like this guy. What about this guy? He's a what? He's a quadratic. He's a parabola. Now, his typical equation is y equals x squared. So what did we do to him? Well, here's the origin. We went over 1 unit, didn't we? Did we move up or down? We didn't move up or down, but we did move to the right 1 unit. So I got to mess with that x. I slid to the right 1. That means I'm going to subtract 1 to make it move to the right. Okay, so that's what we have there. You didn't move up any. Now, do not put +0. I don't need to know that's +0. I don't want to say, hey, how old are you? And you're like, oh, 6 plus 0. You don't say +0. If you're adding nothing, there's no sense in even putting it. However, what do you notice with this graph? A typical y equals x squared is facing upwards. This has been flipped over the x-axis, reflected over it. You need a negative out front. You need a negative out front. Don't forget that. That's important. If it's facing downwards, you've got to pay attention whether it's been reflected over that x-axis.